Hi, welcome. My name is Mohit, and in this video, I'm going to talk about the NVIDIA RAPIDS framework, which is a collection of libraries that accelerate data science workflows using NVIDIA GPUs. So obviously, it's based on NVIDIA CUDA, but apart from accelerating the workflows, a really nice thing about RAPIDS is that it makes it really easy to transition from traditional Python workflows to NVIDIA GPUs. It's open source and all the code is available on GitHub, which enables collaboration and community development. I came across this framework quite recently, but it has been around since 2018. And I just did not know about it, which is to some extent shameful because I have been using large amounts of data, but I was not involved with NVIDIA GPUs, so I never thought about this. Rapids contains collection of libraries. For example, QDF accelerates pandas and polars, and there's QML that accelerates scikit-learn. I have never used NetworkX, and I've never heard of QGraph before, so this is really new to me. But I have felt the pain of working with large data frames that are extremely slow in pandas, especially while doing operations such as group by, merge. And in this benchmark, we can see that if we use QDF to accelerate pandas with zero code change, we can make pandas almost 80 times faster compared to using regular pandas for group by operations. And we can make merge operations almost 50 times faster using GPU acceleration compared to normal pandas, which is really nice because it saves a lot of time in a normal working day. In the case of machine learning, QML can make linear regression almost 25 times faster compared to scikit-learn, and principal component analysis almost 25 times faster than scikit-learn. So all these benchmarks are really impressive. And especially in this case, here we have QGraph that makes NetworkX almost 500 times faster in some cases, in this one case, and almost 200 times faster in these other cases. All right, so let's look at the ecosystem. So if we click here, we get to this page. I will look into the libraries. So like I said, it's a collection of libraries. We already spoke about QDF, QML, and QGraph, and here we have several more. Here, for example, QVS, this contains optimized algorithms for approximating nearest neighbors and clusters, and other tools for vector search. And here we have another library that's called Quikio. This is to take advantage of the GPU direct storage. Then we have QXFilter. This is to visualize and filter through large datasets really quickly, and also accelerate charting for these large datasets. Then we have QCIM. This is to accelerate computer vision and image processing tasks, especially for biomedical imaging. So if you scroll down, we see that it is integrated into other well-known algorithms, for example, XGBoost, and it's also integrated into cloud deployment workflows and workflows that include using multiple GPUs, and also for visualization, actually. And these are some softwares that have been built using RAPIDS. Quite impressive. So now I want to go to the user guide. So if we click here, use cases, we get to this page. And here there are several user guides for all the workflows that we saw on the previous page. including graph analytics, machine learning, data processing. But I'm only going to look at QDF and QML. So if we click here, we reach the GitHub repository of QDF. Here it says this is a GPU data frame library. Let's scroll down. And here we have small snippet that shows how to import and use QDF, like pandas. So if you look at this code and this code, so the syntax in pandas and QDF is really similar, and that's by design. So if you go deep into the use of QDF and pandas, we might find differences, but they are designed to be really similar. And that's really nice because we don't have to think about syntax while switching from pandas to QDF. Another really nice thing is that if we have existing code that uses pandas, like in this case, for example, we can just put this line here to load QDF.pandas before we import pandas. And then the existing code will be accelerated using GPUs, which is really nice and convenient. So if we go down here, there is documentation for QDF. And if we click here, we'll reach this page. So here we have the complete user guide for QDF. I'm not going to go into the details for this because I will just use it the next time I need it. So for now, I will just move on to the user guide for machine learning. So this is QML. So if we click here, we get to this page. This is the documentation for QML. And here it says this API mirrors scikit-learn and provides a familiar fit, predict, and transform paradigm. So this is similar to pandas, in which we saw that the syntax is really similar, and that's by design. And just like there was a load function in the case of pandas, even in case of QML, we can use this QML.excel to accelerate the existing code that does not use QML natively. So this library is designed to work on GPUs, but it can also function on CPUs in case the user does not have a GPU in their local machine to develop the models, or even in their production machines where the model is going to be used for inference. But if we use GPUs, then it can make the performance 10 to 15 times better compared to the CPU-based alternatives. And this is really impressive because more complex models with large data sets and a lot of hyperparameters that need to be tuned, they can take a long time and slow down the work. So having a fast library allows us to experiment really fast and develop the model really fast. So it's really convenient. Here we see a small snippet as a quick start guide for the library. And apart from the import statements, the rest of the code looks similar to scikit-learn to me. And if you scroll down, okay, so here we have the user guide. So now I want to look at the other tab, that's introduction. Here they have some more information about QML and its similarities with scikit-learn. And they say most of the scikit-learn code works with minimal changes if we just use QML before scikit-learn to accelerate the existing code, which is really convenient. And here they have another snippet that shows how to use QML. And again, it's really similar to scikit-learn, apart from the import statements. Scrolling down, we see really interesting benchmark, which is also obvious, but still nice to see, which says that the performance gains increase for larger datasets. So the larger the dataset, the more it's useful to use a GPU compared to a CPU alternative. Okay, now let's go to the user guide. All right, so user guide, I'm not going to go into the details of user guide again, just like I did not go into the details with pandas. I will end the video here and I will see you next time. Bye-bye.